Could a colossal cloud drifting through space have plunged Earth into an ice age? Imagine, if you will, a vast amorphous collection of gas and dust floating in the cosmic expanse. These are interstellar clouds, mysterious and massive assemblies in the galaxy that might play a more critical role in our planet's climate than we ever imagined. Interstellar clouds, often composed of hydrogen gas and dust particles, are not just isolated celestial phenomena. They are dynamic entities that can interact with solar systems, including our own. The theory suggests that, as our solar system moves through the galaxy, it occasionally passes through these dense cosmic clouds. Such an encounter could potentially shield Earth from cosmic rays, which in turn might trigger significant shifts in our climate, including the onset of ice ages. This isn't just about ice and cold, it's about understanding the interconnectedness of cosmic events and Earth's environmental systems. Now, let's delve deeper into the science behind this chilling possibility. Imagine giant clouds made not of water droplets but of gas and dust floating in space. These are not your everyday clouds that you find in the Earth's atmosphere. These are interstellar clouds, colossal conglomerations of gas and dust suspended in the vastness of space. Predominantly composed of hydrogen, the most abundant element in the universe, these clouds also contain significant amounts of helium and trace amounts of heavier elements, painting a cosmic picture of the primordial ingredients of star formation. Now, to grasp the sheer scale of these interstellar clouds, consider this. Some of these clouds can stretch over hundreds of light years. In perspective, the entire solar system is just about a light year across. So, these clouds are not merely large, they are astronomically enormous, capable of enveloping entire solar systems, including ours, within their gaseous embrace. But what exactly is this interstellar medium? It's a soup of gas and dust that fills the spaces between the stars within galaxies. This medium isn't just empty space, it's a dynamic, swirling mass that plays a critical role in the life cycle of stars. From the densest parts of these clouds, new stars are born, while other regions might remain as diffuse, shadowy backdrops to the stellar stage. The composition of these clouds is fascinating. The dust, consisting of tiny particles of rock, ice, and organic compounds, forms about 1% of the cloud's mass. This might sound insignificant, but it's this dust that contributes to some of the most spectacular astronomical phenomena, such as the birth of stars and the formation of planets. With such immense structures roaming our galaxy, could one have interacted with our solar system? Let's find out. Scientists drill deep into ancient ice to uncover secrets from the past. Ice cores, much like rings on a tree, are time capsules. They are long cylinders drilled out of ice sheets or glaciers. Imagine them as frozen time machines, capturing layers upon layers of snowfall, each telling a unique story of the Earth's past. So how do scientists use them to study past climates and atmospheric compositions? It's simple. When snow falls, it traps tiny bubbles of air. Over time, more snow accumulates, compressing the lower layers into ice and sealing those air bubbles. These bubbles contain samples of the atmosphere from the time the snow fell, so by drilling deep into the ice, we can access these bubbles and analyze the trapped gases. But it's not just about gases, scientists also study the ice itself. Minute impurities, such as dust particles or volcanic ash, can provide clues about past environmental conditions. Now let's talk about sudden global cooling. There are certain points in the ice core record where scientists have found evidence of abrupt climate change. These periods of rapid cooling, known as stadials, appear to have happened in the blink of an eye, geologically speaking. One of the most dramatic of these stadials occurred around 12,000 years ago, a period known as the Younger Dryas. Temperatures in the northern hemisphere dropped sharply, and the flourishing warmth of the early Holocene was abruptly replaced by glacial conditions. But what could cause such sudden, dramatic shifts in our planet's climate? This is where the plot thickens. The data points suggest that these changes could not have been triggered solely by Earth-based events. There must have been an external trigger, something beyond our planet's own climate system. The answer may lie beyond our atmosphere, in the mysterious realm of interstellar space. These icy archives hint at extraterrestrial influences, but what could link them directly to interstellar clouds? Stay tuned as we delve deeper into this cosmic mystery. What happens when the unstoppable force of an interstellar cloud meets the unmovable object of our solar system? This isn't just a science fiction scenario, it's a real astronomical event that could have profound implications for Earth. An interstellar cloud is essentially a vast collection of gas and dust floating in space. When our solar system encounters one of these clouds, it's not just a silent, fleeting moment. Instead, this interaction has the potential to set off a chain of events affecting our planet in significant ways. Firstly, the passage of a dense interstellar cloud could increase the amount of cosmic dust entering the solar system. This influx can fuel the activity of comets. Normally, sedate comets might become more active, their icy bodies evaporating more rapidly as they approach the sun, releasing more debris, and possibly increasing the number of meteor showers Earth experiences. This could result in more particles entering Earth's atmosphere, which brings us to the next potential effect. With increased comet activity and a higher density of atmospheric particles, the Earth could experience changes in solar radiation reaching its surface. These particles could scatter and absorb sunlight, possibly leading to a dimming effect, a reduction in the amount of solar energy that penetrates our atmosphere. In the short term, this phenomenon might not be noticeable, but over time, it could contribute to a global cooling. Now imagine this scenario persisting over centuries. The reduced solar radiation could lead to lower temperatures worldwide, potentially triggering an ice age. This isn't just about wearing extra layers of clothing. An ice age reshapes ecosystems, alters sea levels, and redefines what parts of our planet can sustain life. The implications of such an event are profound, leading us to reconsider the boundaries between space and our atmospheric conditions. As we continue to explore and understand these cosmic interactions, we not only unravel the mysteries of the universe, but also the future of our own planet. Not all scientists are convinced. Let's look at the debates and the supporting evidence. The theory that interstellar clouds could trigger ice ages on Earth is as intriguing as it is controversial. On one side, skeptics question the direct impact of these cosmic wanderers on our planet's climate. They argue that the evidence linking interstellar clouds to terrestrial cooling events is circumstantial at best. These scientists caution against drawing premature conclusions from the current data, emphasizing the complexity of Earth's climate system, which is influenced by a myriad of factors, both celestial and terrestrial. Critics point out that while the idea is theoretically plausible, the actual mechanisms by which an interstellar cloud could significantly alter Earth's climate remain inadequately explained. They call for more rigorous, multidisciplinary research to explore not only the astronomical aspects, but also the atmospheric science involved. Conversely, the supporters of this hypothesis stand firm on a foundation of emerging data and improved observation technology. Advances in space-based telescopes and remote sensing tools have allowed us to better understand the density, composition, and movement of interstellar clouds. Proponents argue that as our solar system travels through the galaxy, it inevitably encounters these clouds, which could potentially reduce the amount of cosmic radiation reaching Earth, thereby affecting our climate. The evidence, they say, is visible in the geological and ice core records that show periodic cooling events aligning suspiciously with estimated timings of such cosmic encounters. Moreover, computer simulations of these interactions suggest a possible correlation between interstellar clouds and reduced solar energy penetration into our atmosphere. As the scientific community grapples with these perspectives, ongoing research is critical. Collaborations across astrophysics, geology, and climatology are being forged to test the validity of this hypothesis more robustly. The quest for more definitive answers involves not only looking back into Earth's past, but also gazing farther into the space through which we travel. As the debate continues, the search for truth drives our scientists to look deeper into the cosmos. As we gaze up at the stars, the mysteries of our past climate changes remind us of our place in the cosmos. Today, we've traveled through a fascinating hypothesis that an interstellar cloud might have triggered an ice age on Earth. These cosmic wanderers, interstellar clouds, are vast accumulations of gas and dust, floating through the emptiness of space, potentially influencing planetary climates as they encounter solar systems. We delved into the historical clues locked within ice cores, which tell tales of Earth's climatic shifts, possibly aligning with the timeline of such a cosmic encounter. These frozen time capsules suggest significant changes in Earth's atmosphere, correlating with periods when our solar system might have passed through these dense celestial clouds. The scientific community remains abuzz with discussions, weighing skepticism against the supportive evidence emerging from geological and astronomical data. This dialogue is crucial as it drives the quest for deeper understanding and more refined hypotheses. While the universe holds many secrets, Each discovery brings us closer to understanding the delicate balance of our existence on this pale blue dot.